All right, so to make this transition from finding the probability for a single individual to working with an average for groups, we need to define two more terms to help us out here. So if we're looking at a single drink, that is most likely the population distribution that we're looking at. So for these frozen sodas, that was normal, 20 and zero point 0.5. But if we're looking at how an average number of drinks is distributed, that's known as a sampling distribution. So, which is the title of chapter 15. So, we're going to start defining this term now. So, if we're looking at the sampling distribution for sample means or averages, and if we meet certain conditions, those averages are going to be distributed normally, same mean. So that's why both of these had a mean of 20, but the standard deviation is going to be divided by the square root of the sample size. And so that's why my standard deviation changed from that single drink to that average of 50 drinks. And we're going to take a look at where that comes from once we finish defining the sampling distribution idea. So the sampling distribution of a statistic, and these are based on a fixed sample size n. So if you're doing these, you would stick with, say, a sample size of 50 when we were finding those average heights of students at Western. And so within that context, I would stay with a sample size of 50. I might repeat this and use a different sample size. Maybe I use 80 students or 150 students. And so within each distribution, it's staying on that same sample size. So this sampling distribution shows the behavior of the statistic over all the possible samples. So if I just kept pulling samples of 50 from Western over and over and over again until I came up with every possible combination of 50, that's what we're talking about here. So it'll show all the possible values that the statistic can take on and how often they occur or that probability. So that height, again, is a probability or how often they occur, just like it was when we were looking at that normal distribution. So this sampling distribution is also a probability distribution, and it's the probability distribution of all the possible values of the statistic by considering all possible samples of the same size n from that population. This describes how a statistic varies in many samples of the same size n from the same population. So a lot of these are kind of different ways of saying the same thing. And so you'll see that often kind of worded a little bit differently, but they're all getting at this idea of taking out of samples, finding the mean for each sample, and plotting all of those means. So depending on the sample size, this sample distribution may look like the original population distribution, or it turns out it can also be normally distributed under special circumstances that we're going to look at. So there are two types of sampling distributions. We're only going to work with the one for quantitative data. So we're only going to look at how means are distributed for all possible sample sizes. But you can also do this with categorical data. And if you're doing it with categorical data, then you're looking at the sample proportion. So the number of wins out of the total tries. So for example, if you are flipping a coin, the number of heads out of the total number of flips, for example. Okay, so now that we've got a little bit of an idea of a sampling distribution, I want to compare and contrast these three distributions that we're going to be working with. So the population distribution, and that's of a variable, shows the distribution of the whole population. So it's all the population data. It's the distribution of the values of the variable for all individuals in the population. So it's every single one. And it describes the individuals that make up the population. So that's our population distribution. We rarely have all of that information. So instead, in the field of statistics, we're often working with the distribution of the sample. So this shows the distribution of the sample data, the distribution of the values of the variable for all individuals in the sample. So that's a much more achievable thing than finding the values for all of the individuals in the whole population. This typically is going to look like the population distribution. So if the population is normally distributed, your sample will be as well. So if you are reading a problem and it claims, oh, the original population was normal, that gives you automatically that you can apply those normal properties on the sample. So these are two groups that we've kind of really worked with in the class. Now I want to add this new sampling distribution, which is what we're getting into in chapter 15. So rather than finding the distribution of a variable, now we're finding the distribution of a statistic, this thing that we're calling a random variable. So this is going to show the distribution of the mean or the average from all of those samples. So rather than for each individual person, now what we're looking at is the distribution of the value of the mean for every possible sample size of every possible sample of the same size. So every sample of 50 is what's going to get plotted into here. Depending on a sample size, it may look like the population distribution, or it can be normally distributed. And that's where we're headed next, is when do we get to claim that normal distribution so we can use all of those properties that we learned in chapter 3.